Okay, so we're going to wrap up chapter 5 video. What we're going to start with is section 5.3, special factoring. Special factoring because what we have here are basically formulas that you'll need to have memorized for your test. What you can see here is that they're discussing factoring a perfect square trinomial. And basically the pattern you want to look for here is that we would have an x squared or some variable squared, and then either a variable or a number that is also a perfect square. And then you just want to look for the plus or minus. You also need to be aware of slightly that there's this 2xy pattern, and the first sign is going to tell you if it's a plus or a minus. A lot of times when you have the perfect squares on either end, the middle works out. So let's do some examples. So for a here, we see that we have an a squared, which we know can be broken up into a and a, right? A times a will give us a squared, so we're good to go. 36, the perfect square of 36 is 6. Okay. And then we need to look at this sign. So they're both pluses. So then we could write this as a plus 6 quantity squared. Now to check to see if you were right, you could either go back to what the pattern says, which that would mean that you would be checking the middle term for 2xy, which in our case is 2 times a times 6, which is 12a. You can see that they match. The other thing you could do is you could just FOIL, and when you FOIL, you are going to get right back to what we were given. Okay, let's look at the next one. 16x squared, the perfect square of 16 is 4. So we'll have 4x and 4x. The perfect square of 49 and then y squared will be 7y. And we actually have a negative, so they'll both be negative. So then we would rewrite this as 4x minus 7y quantity squared. Again, if you wanted to check, you could either FOIL, and you should end up right back here. Or if you want to do this pattern, you would be looking for 2xy, which in this case would be negative 2 times our x, which is 4x, times our y, which is 7y. So that would be 28 times 2 is 56xy. Okay, so it does match and it does fit that pattern. Okay. All right. C. We'll see, I can go straight from here. Actually, C is a little bit different. So let's look at this a little differently. What we notice here is we have a trinomial that is also a perfect square. So we have our y squared and we have 64. Y squared gets split up into y, and then the perfect square of 64 is 8. And then we have a negative, so it's minus 8 minus 8. So we can rewrite that as y minus 8 quantity squared minus z squared. Again, we have now a perfect square binomial. So we would write that as y minus 8 plus z, and then y minus 8 minus z. And the reason why the z's need to have a plus or minus is because, do you see how we have a squared term and a square term? We do not have a monomial term in the middle. So those terms are canceling out. So that is how we are doing that one. Okay. Factoring a difference of cubes, you need to know this formula. Okay. So let's do A. T cubed minus 1. So it is a difference. In this case, our x is going to be t and our y is going to be 1. So anywhere you see in the pattern or in the formula where there's an x, we're going to put a t. Where there's a y, we're going to put a 1. So it's just going to be t minus 1. X squared will be t squared. Xy will just be t, so plus t, because 1 times t is t. And then plus y squared, so that's plus 1 squared. 1 squared is just 1, so plus 1. So this is your answer for that problem. For B, we have 125a cubed minus 8b cubed. Our x is equal to 5a. Our y is equal to 2b. Again, we're going to plug in anywhere we see x, we're going to use 5a. Anywhere we see y, we're going to use 2b. Sorry about that. Okay. So 5a minus 2b. X squared will be 5a quantity squared, so 25a squared. Xy is going to be x times y, so 5a times 2b is going to be 10ab, so plus 10ab. And then times y squared, so plus y squared. Y squared is going to be 2b squared. So 2 squared is 4, and then b squared, so 4b squared. I can show you that again with the 5a as well. So here is your factored solution. Okay. Okay. The next thing we're going to look at is sums of cubes. It's pretty similar. What you need to focus on is here, if we have a negative in the problem, then we have a negative to begin the solution. Then the next sign is the opposite of the first signs. And the x and y squareds will always be positive. Again, look at the problem. The signs will be the same to start, opposite, and then always positives. All right. These are just a summary of all the forms that you will want to know for the test. So know for exam 3 and final exam. Okay. You can pause this for as long as you like. Write it all down, figure out some little different things to help you remember. Whatever you would like to do. Okay. Factor each polynomial. So here we're using the perfect cubes, and these are all sum of perfect cubes. So exercise 4. All right, A, we're looking at 1,000 plus z cubed So our x here is going to be the cubed root of 1,000. Well, that's 10. And then y is going to be z. So we'll have 10 plus z. X squared is 10 squared, so 100 minus, because it's opposite sign, 10 times, or x times y, so 10 times z, and then plus y squared, which in our case is z squared. Okay, so that will give you the answer there. Okay, and you can see I've been doing this for so long that I have that memorized, but I just talk it out. Okay, so 81a to the 6th plus 3b cubed. So the first thing you need to realize here is we have a GCF, and that GCF is 3. So then we would have 3 on the outside, 27 a to the 6th plus b cubed. So then that's going to give us an x equal to 3a squared and a y equal to b. So how we get the x here, the cubed root of 27 is 3. How we get a squared is, remember, when we take a power to a power, we multiply. So that would be a to the 6th. So we need to figure out the perfect cube. That's going to be a squared. Okay, so definitely helpful to know some of your cubes for the test, but again, you do get to use a calculator, so there is that. All right, so for our answer, we're going to have to keep the GCF outside, and then everything else is the same. X, it's a sum, so x plus y, so 3a squared plus b. X squared is going to be 3a squared squared. So that's going to be 9a to the 4th. And then it's opposite sign. So minus x times y. So that's just going to be 3a squared times b plus b squared for y squared. And that's it. All right, C. C is a little bit different because we are going to have to do some extra steps. So I hope I have enough room. Let me move over in case we end up needing to use the whole space. So we have x minus 3 cubed plus y cubed. So our x is actually going to be the binomial x minus 3, and y is just y. So we would have x plus y, so x minus 3 plus y. Okay, and then x squared is x minus 3 squared minus x times y, so y times x minus 3 will work, and then plus y squared. We can't leave it in this gross mess, so what we have to do is we have to FOIL this part and then distribute this part and combine. So here we'll have x minus 3 plus y. And then what I'm going to do is I'll FOIL up here. So we'll have x minus 3, x minus 3. Okay, that comes from the x minus 3 squared. So there's 2 of them. We'll FOIL. Okay, so we'll get x squared minus 3x plus 9. So that would give us x squared. Well, we'll put it back in the problem now. That'll give us x squared minus 6x plus 9. We'll distribute and we'll get minus xy plus 3y plus y squared. Okay. Don't think anything else can come together. No, it cannot. So that very long thing is your answer. There's a chance you'll have one of these or something similar to it. We'll see. It just depends on the other problems that I have to choose from for your test. Okay, on to section 5.4, a general approach to factoring. First thing you always want to do is you want to factor out that GCF. The how many terms part definitely helps with if you're dealing with a binomial or a trinomial. So binomials, you're going to have difference of two squares, difference of cubes, or sum of cubes. All right, so those are all the ones with formulas. Trinomials, you'll either have the x squared with a 1 in the front or the ax squared with other than a 1 in the front. And I showed you guys this method of taking a times c to get to b. The FOIL method I did not cover. I just think that'll be way too confusing for you guys to have two options there. If a polynomial has more than 3 terms, so in other words 4, you want to use grouping. I do not believe your test will have any more than 4 term questions. But if you were to have more than 4, you want to use grouping for anything that has more than 3 terms. If any of the factors can be factored further, then you should always check and do so. And then finally, the check is to multiply to get back to the original. Okay, so here's our question for section 5.4. We need to figure out what we can pull out from 13 and 39. Well, the factors of 13 are 1 and 13. The factors of 39 are 1 and 39 and 3 and 13. So we can actually pull out a 13 and we're left with x plus 3. And if you foiled that, or sorry, not foiled, if you distributed that, you would get back to the question. So we know that we did that one right. 21x cubed y squared minus 27 x squared y to the 4th. Sometimes it helps, like I said, talking it out or writing it out will help. 21, the factors of 21 that will help you will be 3 and 7. And so then we can also take 3 out of 27. So 3 and 7 help us get 21. 3 and 9 help us get 27. So we're going to pull a 3 out for sure. Your GCF up here was 13. Right, and your GCF here is going to be 3x squared y squared. Remember, you want to go with your lowest powers. Okay, so that's going to give us a 7x and no y left, and then a 9, no x left, y squared. So here the GCF was 3x squared y squared. Okay, see? What you need to realize from C is that you have kind of like a grouping problem already partially done for you. And you need to realize here that we have matching parenthesis sets. So your GCF here is actually m minus n. We're going to bring our outside terms together and only write the matching parenthesis set once. Okay. All right, D is a little weird. So I'm going to write it so that you can see it all in one place. Okay, you can see here we have two y minus 1s. So that's your GCF. So GCF of y minus 1. So we're going to pull y minus 1 to the front. And we're going to be left with 2y plus 1 minus y plus 4. We'll distribute this negative throughout. So we would get y minus 1, 2y plus 1 minus y minus 4. So we would end up with y minus 1, which is our GCF. Let's work on the combining like terms here. So 2y minus y will give us y. And then 1 minus 4 will give us a minus 3. Again, if you were to foil these two out for D, you would end up getting back here. I think that was asked to be shown. I can show you guys. If you're interested in seeing that, let me know. I don't want to make this video too long, so just let me know if you would like to see that. Okay, so this is the last section, 5.5, and it is talking about this zero factor idea. So whenever we want to solve a problem, we want to get the factors. So we want to get the problem into factored form, and then we want to set each factor equal to 0. So in this case, they've already made it kind of nice for us, and we have it in factored form. So we're just going to set each factor equal to 0 and solve to get our x's. Okay, so our most correct way of writing this is to say that x is equal to the set of -5 and 7/4, meaning those are the only two solutions we have for this equation. I would also accept if you gave it to me like this. Okay, so either way, I'm not too picky. I'll be really happy if everyone can get their solutions. So not the end of the world to me if it's not perfectly written. Okay, so to solve these equations for the most part, you want to write the equation in standard form, which is to say all the terms on one side of the equality symbol in descending powers according to the variable, with the other side of the equation being 0. Factor completely, apply the zero factor property, solve the resulting equations, and then check with the original and write the solution set. So actually, I feel like this probably should come first, and that's fine. Let's do this real quick for you guys. Let's take this and bring it into here. Perfect. All right, that's a better slide for you guys. Okay, so what I'm going to do here, since I have a little bit more room that opened up, I'm going to actually show you guys how to do a check. Okay, so all we would do is we would plug in -5 for x. And here's the thing, we don't even have to worry about the second part, like this part. Like no matter what that is, right here is giving us a 0. So this number could be literally anything, and anything times 0 is going to give us a 0. So the -5 checks. Same thing if we plug in 7/4. Here we would have 7/4. And no matter what this is, even though you don't like doing that, we don't have to worry about it because the 4's cancel. Fours cancel. So then we're left with 7 minus 7, which is 0. 0 equals 0. So that's true. So then 7/4 also matches. Okay, so now we have that really good slide for you. Okay, so here's what we're talking about when we are wanting to say quadratic equation. Ax squared plus bx plus c equal to 0, okay? So this is a reminder of what standard form is, and we typically almost always will have or try to have a positive in the front. Some of you had asked in class, can we have the negative in the front? You can. I would just not recommend it. If you can rewrite it so that you can get the x squared or whatever variable squared to be positive, I would absolutely go with that option. Okay, so this is going to give us 6x squared plus 7x minus 3 equal to 0. We can't pull anything out, so we're looking at 6 times 3. Remember, that's our process. And then we want factors of 18 that'll add or subtract to give us 9, to give us 7, and that's going to be 2 and 9. So we'll have 6x squared minus 2x plus 9x minus 3 equal to 0. We're going to factor by grouping. So we're going to pull a 2x out and we'll have 3 minus 1, 3x, sorry, minus 1, plus we're going to pull a 3 out and again 3x minus 1. So we're left with 2x plus 3 times 3x minus 1 equal to 0. We're going to split those and set them both equal to 0. And I do not think I'm going to show you how to check this one, but if this was an exam question, you would have to check it. So the most correct way to write this would be the solution set of -3/2, comma 1/3. Okay. Again, I will take it written alone as well. Okay. And again, you would want to plug in for both and check. Okay, for this one, we can see it's not in standard form and we don't have a 0 on either side. So we're going to go ahead and add 4x and add 25 to both sides, or sorry, 40x and 25 to both sides. And that's going to leave us with 16x squared plus 40x plus 25. What you really need to see here is this would be classified as a perfect square trinomial. That being said, for you, you can then go straight to parenthesis sets. And you can say, well, the perfect square of 16x squared is 4x. The perfect square of 25 is 5. Our middle term is positive here. So stop it. So we're going to do a positive. You could write that there as well as 4x plus 5 quantity squared equal to 0. Okay. So we're going to set, we only have to solve this one time, but there is 2 of them. So we'll do 4x plus 5 equal to 0. Subtract the 5. 4x equals minus 5. Divide by 4, divide by 4. Then we have negative 5/4. Most correct way to write this would be the set of negative 5/4. And then you want to say duplicity. Okay. Another way to say that is a multiplicity of 2. All that tells you is that your answer or solution really is showing up twice. And that's because of right here, that power gives you the duplicity. Okay. Do you absolutely need that for your test? No. But just in case you would be wondering, hey, why do we only have 2 of the, or why do we only have 1 answer when we are used to having 2? And that would be why. Okay. That is du, by the way. Duplicity. du. Okay, duplicity. All right. This one's a little different because we have a GCF. The GCF is 3x. So let's pull 3x out. We have x plus 4. We're going to split these. Divide by 3. Subtract 4. So x is equal to the set of negative 4, 0. Again, you could plug in to solve for this. We can plug it in verbally. Negative 4 quantity squared would be 16. 16 times 3 will be 48. 12 times negative 4 is a negative 48. 48 minus 48 will give us 0. And then, of course, when you plug in your zeros, you get 0 equals 0, which is also true. So I guess I'll do that check really quickly for you. 3 times negative 4 squared plus 12 times negative 4 equals 0. That's 3 times 16 plus negative 48. So 48 minus 48 equals 0. 0 equals 0. True. So negative 4 works. And then the check for 0 is just 3 times 0 squared plus 12 times 0 equals 0. 0 plus 0 equals 0. 0 equals 0 is true. So the 0 works as well. Okay. Here you can do a couple of things. We can solve it using one method. Stop that. Okay. Method one is you guys could see that this is a perfect square binomial. So we could go straight into our parenthesis set. And we could have 2x, 2x, and then plus, because we get that by the square root of 4x squared, and then we would have plus 10 and minus 10. Set them both equal to 0. Sorry guys, getting tired again. Okay, the second method, method 2, is probably what I would consider the more correct method, only because we're always taught to pull out a GCF if we can find it. So that GCF this time would be 4. So we would pull out a 4 and we would get x squared minus 25 equals 0. Again, this inside is a perfect square binomial. So we could go straight into the split. And it would be x and 5 and 5 with a plus minus, whichever way you wanted to do it. And then x minus 5 equals 0 and x plus 5 equals 0. So we would get x equals 5 again, or x equals -5. The other thing you can see here as well, and again, it would depend on how you would want to, like I said, see what's going on. You could see this as well. You could go straight from this part and go, okay, x squared minus 25 equals 0. Add 25 to both sides. X squared equals 25, square root of both sides. X is equal to plus or minus 5. Again, I don't care how you want to do it. Any of the methods are fine with me with that approach. If you have any questions on it, email me, ask me during the review on Monday, whatever you want to do. Okay, almost done. So first things first, let's FOIL and distribute. So x plus 3, 2x minus 1, 4x plus 4 minus 4. We'll distribute and we'll FOIL. So 2x squared plus 6x minus x, minus 3 equal to 4x plus 16 minus 4. These come together, so we have 2x squared plus 5x minus 3. 4x, these come together, plus 12. So we're going to subtract 4x and subtract 12. So we're going to get 2x squared plus x minus 15 equals 0. Here we need to realize that we can't pull anything out. So, and we have a more than one up front. Let me rewrite this because now it should be jogging your memories on how to solve this. So we're going to do 2 times 15, and that gives us 30. We need factors of 30 that have a difference of 1. And that is 5 and 6. So 2x squared, we actually need a positive 6 and a negative 5. So minus 5x plus 6x minus 15 equals 0. We're going to go into grouping. Only thing we can pull out here is an x. Here we're going to pull out a 3. So we'll have our outsides brought together because our parentheses match. And we're going to set them both equal to 0. Okay. Remember, your most correct answer here would be the set of -3, 5/2. All right. And don't forget that you would want to check that. So that is it. That's everything that's going to be on the exam for Unit 3. I will be making your exam probably tomorrow, and making your review. We will have the review on Monday. I might record it just because I think factoring is really hard. If I do that, then I'll probably record it tomorrow as well. But I won't release it until after class on Monday. All right, I'll see everybody on Monday. Have a great productive weekend. Bye, guys. Oh, also, there is a Q&A session for tomorrow, Friday, 10/1, from 12 p.m. to 2 p.m. All right, whoever wants to join, it'll be the Canvas link that the Zoom link and Canvas that we normally use for class. All right, bye, guys.